In previous class we have learned that all the laws of algebra in the sets, which are idempotence law, identity law, next commutative law, associative law, and others, De Morgan's law, distributive law. Okay, now today we will applying these laws of algebra. We will prove some properties or some problems. Okay, first, applying laws of algebra, prove that A union B minus C equals to A minus C union B minus C. Okay, we have to prove A union B minus C equals to A minus C union B minus C. So we will start from left hand side. Okay, A union B minus C, which will be, now by the complementary law we know that A minus B equals to A intersection B complement. Okay, if we apply these laws in this part, we get A union B intersection C complement, right? Now here union, this is intersection. Now we can use the distributive law, but we have distributive law when A union B intersection C, right? Okay, so we will use the commutative law. Commutative law will be intersection A union B, right, by commutative law. Commutative law. Okay, now if we use the distributive law, we will get C complement intersection A. Now this is intersection over union, so C complement intersection A union C complement intersection B, right? Now if we use the commutative law again, this is distributive law. Now if you use commutative law again, we will get A intersection C complement union B intersection C complement. Okay, so again if we use this first law, we will get, for this two part, we get A minus C union B minus C, well, which is right hand side, proved, right? And this is also commutative law. So you don't have to write this part, okay, as there will be a MCQ answer, so it can be questioned as this part is given, so what will be the equivalent to, this part is equivalent to some of the following, one of the following. Okay, the A, B, C, D, there will be 4 options. Which one will be true? One of the answer will be this, so this is the part is answer, this part will be answer, true answer. Okay, this is a simplification form or some proof. There will be many questions. Okay, next, A intersection B minus C equals to A minus C intersection B minus C. Okay, we have to show A intersection B minus C equals to A minus C intersection B minus C. So usually we will start from left hand side, which is A intersection B minus C equals to, same way, A intersection B intersection C complement as A minus B equals to A intersection B complement. B complement is the complement of B, here C complement is the complement of C. So now A intersection B, if we use the idempotent law defines as A intersection A equals to A. Okay, so C complement, we can write C complement as C complement intersection C complement, which is also C complement. Okay, now we write this as associative law. A intersection, here all are intersection, so associative law can be used. A, B is associated to A, then this part is associated. Now we will write A separated and B will associated this term. So B intersection C complement intersection C complement. Okay, now we will associate B with only C complement. Here C complement and C complement associated to each other. Now we will C complement associated to B. So B intersection C complement intersection C complement we can write. Now if we use commutative law, this part and this part. Okay, if we use commutative law, we can write C complement intersection B union B intersection C complement. Okay, now we can associate C complement as with A and this part will be separated. Then we will get A intersection C complement intersection B intersection C complement. Okay, so now by the property of this we will get A minus C intersection B minus C. Okay, which is the right hand side. Okay, so this way we can prove some of the results. I have given in the study material, I have given another 2 example and do homework. Try it yourself at home. Okay, now example 3. How to find the HCF and LCM of some numbers by set theory. Okay, if there are given some numbers, let's see, 6, 15 and 21. Okay, this will the LCM of these numbers will be difficult to collect. Okay, 21 7 42. This number is just 18. Let's say 18. Okay, 6, 15 and 18. Now the HCF of 6, 15 and 18, we have to find the HCF of 6, 15 and 18 and LCM of 6, 15 and 18. So how to find the HCF and LCM by set theory. Now what is HCF? The highest common factor. Okay, and LCM is the lowest common multiplier. So first we will find the HCF. To calculate HCF, let A, B, C be 3 sets such as A is the set of all factors of 6, B is the set of all factor of 15, and C is the set of all factor of 18. All factor, okay. So if we write as 6 is in 2 3 15 as 3 5 18 as 2 9 3 3, okay. So all the factors of A, all the factor of 6 will be 1 is always a factor, and next 2 is a factor, 3 is a factor, and 6 also itself is a factor. Factors means the numbers is divided by divisible, okay, by 6, or 6 is divisible by the numbers. These will be the factors of 6, okay. B equals to the factors of 15, okay, which 1 3 5 and 15, and C is the factor, right, which will be 1 2 3, okay. Next 3 and 2 6, 3 3 9 and 18 itself, okay. So A intersection B intersection C will be the common numbers. The common numbers are 1 3 1 3 1 3, okay. These are the common numbers of 3 sets. So this will be 1 3, okay. Now HCF equals to highest common factor of A B C. So greatest factor or greatest element of A intersection B intersection C, যেহেতু this is called highest common factor of ABC, that means the greatest element of A intersection B intersection will be the HCF of the numbers, okay, which is the highest element, which is 3. So HCF will be 3, okay. Now for LCM, now for LCM we have to find the multipliers of the numbers, okay. So we will take 3 sets. Let x is the set of all multipliers or multiple of 6, y the set of all multiplier of 15, z equals to set of all multiplier of 18. So x equals to the set of all multiple of 6, which are 6, next 12, next 18, next 18 12 6, this will be 24 30 36 42 48 54 60 66 72 and so on. Y will be the multiple 50, which are 15 30 45 60 75 90 105 120 and so on. Z equals to the multiple of 18, which are 18 36 54 72 90, 108, and so on. So if we multiple of 6, if we calculate the multiple of 6, there will be a number which is 72, 80, 78, then up to we will get a 90 will be the multiple of 6 also. So x intersection y intersection z, the first common numbers will be 90, right? Next 180, okay, and so on. If we calculate these numbers, we will get the first common digits of x, y, z common element will be 90, okay, and there will be no common element below that 90, then 180, and so on. Okay, so LCM will be LCM equals to the lowest common factor. That means least common common multiplier. Common multiplier. This common multiplier of a x, y, z, which will be the least value of x, y, z. Okay, least value of x, y, z means x intersection y intersection z. The least value will be 90. And this is the LCM of these three numbers, 6, 15, and 18. That's how we will find the HCF and LCM of the given numbers by set theory. Okay, I have given 2 questions and also an example I have already done in the study material. Okay, let's see.